All right, so in 2.10, we are talking about perpendiculars and distance. So when we talk about the distance segment, all right, the distance segment is basically the distance from a point to a line, or the distance between two parallel lines, okay? But bottom line is when I measure the distance from a point to a line, imagine you're standing in a room, right? If I'm standing in a room and I'm trying to find the distance from me to a wall, I measure straight towards that wall, right? Perpendicular to the wall, the closest possible distance. I don't go to the corner of the wall or the other side of the wall. I go straight perpendicular to that wall. Same thing, like if you're in a plane, the altitude of the plane is not measured, at a diagonal, right? It's measured straight down to the ground, perpendicular to the ground, right? So if you have a point and you have a line, you have to measure perpendicular from the point to the line, and then this would be the distance. All right, so always from a point to a line is that perpendicular distance. Same thing is true if I had two parallel lines. All right, let's say I had these two parallel lines, and let's put the arrows to mark them parallel. I would have to, if I'm finding the distance between them, I would have to find that perpendicular segment distance. Okay, it's got to be perpendicular to both. That would be the distance. All right, same thing there. So if we are looking for the distance from a point to a line on the coordinate plane, all right, we have 4 steps. All right, I'm going to write the problem here. All right, the problem is line L contains points 2, -3, and 6, 9. We want to find the distance between L and point W. All right, point W is located at -3, 5. All right, so I've got this line that has these 2 points, and then there's another point that's off the line, and I want to know the distance between W and that line L. All right, so first step is we're going to try to find the equation of the line. That's my first step. All right, so step 1. Step 1. All right, find the equation of the line. Well, if I'm looking at these 2 points, I have to find the equation of the line. So my slope is going to be y2 minus y1 over x2 minus x1. So this is going to simplify to be 12 over 4, which is just 3. All right, so we know the slope of that line is 3. And then I can take either of these points, right? They're both x and y coordinates. So I can take y equals mx plus b. Let's take the first point right here. So I'm going to plug in a -3 for the y. We know the slope is +3, and the x value for that point is a +2. All right, we do not know the y-intercept yet, so we're going to find it. We've got -3 equals 6 plus b. When we subtract the 6, we get a -9. So -9 is b. All right, so overall, my equation of this line L, so let's say line L equation, y equals 3x minus 9. All right, that's the equation for line L. And I did go on Desmos, and I did do some graphing here, so you can see that there is line L in the red. So this is line L. That's what it looks like. And you can see it does go through the 2 given points that we had. All right, so everything's good so far. Step 2, all right, we want to write the equation of a line perpendicular to that line through the given point. All right, so we want to think of a line that is perpendicular to this line L. All right, well, I know, since this is step 2, if I want a perpendicular line, I need the opposite reciprocal slope. So the opposite reciprocal of 3 is -1/3, right? So I know that the slope of this new perpendicular line has to be -1/3, and it is going through this new point, right, through -3, 5, right? It does not have a y-intercept of -9, right? That -9 is for this other line, right? This -9 is not for the new perpendicular line that I'm making, right? I still have to figure that out. So I'm going to take my y equals mx plus b. I know that this is going through point W, so the y value is 5. We just said that the slope was -1/3, and the x value on W is -3 plus b. All right. right, so I'm going to go ahead. This is 5 equals positive 1 plus b. So we know that b has to be 4. So that means that the slope of this perpendicular line is negative 1/3 x. The y-intercept is 4. And this should be the equation of the perpendicular line that goes through w. So let's check this out. We can see that it is perpendicular, right? We get that right angle that's formed right here. And it does, in fact, go through point w. So that's perfect so far. All right, so step 3, we want to solve a system of equations to find the point of intersection. So basically, we're looking for where the purple, which was our perpendicular line, intersects line L, the original line. All right, so you can kind of already see the answer of what we should expect to get. But the reason why we do this is because in order to find the distance from this point to this line, I need to know 2 endpoints. So I have to find this point of intersection first. All right, so when I find the point of intersection, and again, I'm kind of running out of room here, so I'm going to erase some stuff I've already done. All right, there we go. All right, so step 3. All right, hopefully you don't have to erase anything. You should have enough space on this page. Solve a system of equations. All right, so my first equation was y equals 3x minus 9. The new equation we just had was y equals negative 1/3 x plus 4. All right, so I'm going to go ahead and set these equal to each other because they're both equal to y. That's a transitive property. So 3x minus 9 equals negative 1/3 x plus 4. I'm going to move the negative 9 over here, which would give me a positive 13. And I'm going to add 1/3 over here. So that would give me 10/3. And then I got to multiply by the reciprocal to get x by itself, right? So times 3/10 on both sides. So that means that x is going to be 39/10, which is just 3.9. All right, so we found the x value, which is great. But now I got to plug it in and I got to find the y value, right? Because I'm trying to find the location of this point. And you can see we do get a 3.9 there for x. So when I plug in a 3.9, I would say the first one's going to be a little bit easier. But I'm going to go ahead and we're going to say y equals 3 times 3.9 minus 9. All right, so we end up with y equals, now if you're looking for 3 times 3.9, my recommendation would be to do 3 times 4, right? So it's something close to it, and then you're just going to subtract the 0.3, right? Because it's 0.1 difference 3 times, so you're going to subtract that 0.3. So this should give us 11.7. All right, 0.3 less than 12. And this is going to be 2.7. All right, so the point of intersection is going to be 3.9, 2.7. And you can see that that is, in fact, what we get when we look at the intersection point right there. All right, so now we just have to find this distance. All right, so that's this distance formula problem now. I could also use Pythagorean theorem, because remember, Pythagorean theorem and distance formula are the same. All right, so let's just use distance formula. So step 4, we know the distance is the square root of the the difference in x values squared plus the difference in y values, squared. All right, so if I'm looking at my negative 3.5 and my 3.9, 2.7, we're going to plug in, let's see, so 3.9 minus a negative 3, so plus 3. And then we've got our y values, which is 2.7 minus 5 squared. So this is going to be the square root of 6.9 squared plus negative 2.3 squared. And honestly, this is just a calculator problem right now. But when you type this in your calculator, you should end up with approximately 7.27 units. All right, so that's the approximate distance between the point W and the line L. All right, so that's going to be that perpendicular distance right there. All right, let's try another one. All right, this time we're looking for the distance between 2 parallel lines. All right, so you can imagine, well, this is what the situation is going to look like down here. All right, Desmos is a great graphing tool, so you can use Desmos. All right, so I'm gonna give you a problem. Let's say we wanna find the distance between y equals 2x plus 3 and y equals 2x minus 1. All right, obviously we know these are parallel because they have the same slope, which is 2, so they are parallel. So we did find the slopes already, that's taken care of. Now we want to sketch a line perpendicular to both. All right, so if I'm looking for, this is step 2 now. If I want a line perpendicular, that means I'm looking for the opposite reciprocal. And the opposite reciprocal of 2 is negative 1/2. All right, so I know the new slope. When I'm looking for the intersection point, so in step 3, I'm looking for the intersection point between the perpendicular line and the line with the intercept. So these both actually, I could use either intercept for this case. So you can see that we the blue line is going to intersect the y-axis at positive 3, and the red line intersects at 0, negative 1. So you could use either of these points. Either way, the distance here and here would be the same, so it's not going to make a difference which one you use. I just chose to use the negative 1 down here, so up to you, doesn't make a difference. All right, but if I'm looking for the equation of the perpendicular line, all right, this is kind of a combo with step 3 here, right? Because the opposite reciprocal, of 2 is negative 1/2. So if I'm looking for my y equals mx plus b, we know that the slope is negative 1/2. And the question is now, what do I put in for x and y? Well, x and y, I have to know a point on one of these two lines. And we just said that we know, we know the y-intercept of y equals 2x minus 1 is negative 1, right? That's my y-intercept, okay? So that means I can put in 0, negative 1, 0 for the x value, negative 1 for the y value, and that should tell me my b value. And obviously it should make sense that b is negative 1, right? Because it has the same y-intercept, right? So we should have, we could have already known that without having to go through that whole plugging in process. And so we end up with an equation, y equals negative 1/2 x minus 1. All right, this is the perpendicular slope. This is the y-intercept of both lines now. All right, and you can see, right, the red line was my y equals 2x minus 1. And we did perpendicular, right, so slope of negative 1/2. And it also has a y-intercept of negative 1 right there. All right, so you can see that the red and the purple are exactly what we have so far. Right, there's the red, this is my other equation in the blue, and this is the new equation that we just made in the purple. All right, so going back up here. All right, step 3 here, find the intersection point between the perpendicular line and the line with the intercept. We just did that, right? That is the y-intercept. And then we want to write the equation of the perpendicular line, which we just, sorry, I got a little bit ahead of myself. This is steps 2 and 3 and 4. Sorry about that. Did it all at once. Then we want to find the other intersection point. Okay, so we want to figure out where this line intersects the blue line, right? Where the purple and the blue are going to meet each other. So to do this, we're going to have to do a system of equations again. All right, this is step 5. We want to know where the perpendicular line, that negative 1/2 x minus 1, is going to be the same as the equation of the blue line. So I can just go ahead and use the transitive property. So we know negative 1/2 x minus 1 is equal to 2x plus 3. All right, so I'm going to go ahead and I'm going to move the 1/2 x over here. So this is going to give me a 5/2 x, right, 2.5. If I subtract the 3 over there, we get a negative 4. So when I multiply both sides by 2/5, all right, 2's cancel, 5's cancel. We find out that x is equal to 2/5 times negative 4, which is negative 8/5. All right, this is also equal to negative 1.6. And you can see we get the negative 1.6 right there. All right, now I'm gonna go ahead and I have to plug it back in. I'm gonna plug it into this one right here. It looks a little bit easier. All right, so when I go ahead and take my y equals 2x, I'm gonna replace the x with a negative 1.6. And this is equal to negative 3.2 plus 3, which is just negative 0.2. So the point of intersection should be negative 1.6 comma negative 0.2. And that is it right there. Okay, so now we're at the last step here. We found 2 points on the lines, right? We know this line is perpendicular to both lines, and we found these 2 intersection points, so we can just go ahead and we can find the distance, all right? So we're gonna use the distance formula. All right, this is step 6. All right, we know the distance formula is the difference in the x values squared plus the difference in the y values squared. So if I look at the x values, this would be 0 minus a negative, so 0 plus 1.6. And then over here, we've got negative 1 minus a negative, so plus 0.2, which is going to be negative 0.8. All right. I guess I should have written that out, but that's okay. All right, so this is going to end up being the square root of 1.6 squared plus negative 0.8 squared. And this is going to come out to be approximately 1.79. Don't forget your units. I think I forgot units on the one above. Sorry about that. Let's go back to that one. Don't forget units. Oh no, I remembered units. There we go. All right, so make sure you got your units. But it's kind of the same process for both, right? Notice how you just, find the equation of the line, find perpendicular lines, find the point of intersection, and then once you've got the other point of intersection, right, once you got your 2 points, just use the distance formula. Same thing over here. Here they give you the point. Oops. Here they give you the point. Nope. Sorry. They give you this point, and you have to find this point. But either way, once you get those 2 points, you're just looking for the distance between them. All right. So please let me know if you have any questions. I'll be at school on Monday again, so you can see me before school on Monday. And best of